Before we explore the declaration, it's essential to grasp the significance of what's at stake. The Large Hadron Collider, LHC, operated by CERN, marks a monumental achievement in scientific progress. Spanning 17 miles, this sophisticated array of superconducting magnets stands as the largest and most powerful particle accelerator ever created. It serves as a symbol of human creativity and the extraordinary accomplishments we've made in understanding science. Astonishingly, the LHC is capable of creating the same conditions as those present during the very beginning of the universe. However, as we venture into the cosmic unknown, a crucial question arises. Could this machine, which aims to reveal the universe's deepest secrets, also expose us to unforeseen risks? Founded in 1954, CERN is one of the world's most respected scientific institutions. With 23 member nations and a vast community of investigators, it serves as a center for collaborative research and groundbreaking discoveries. Although the LHC is its flagship project, it is just one part of a wide range of particle experiments and accelerators. Think of it not as a racetrack for cars or horses, but as one for subatomic particles engaged in a high-stakes race to test the limits of speed, precision, and the very essence of space and time. Inside the LHC, protons are accelerated to speeds nearing the speed of light, mimicking the energy levels that were present at the moment of the Big Bang. The resulting collisions reach temperatures that far exceed the core of the Sun. A system of magnets guides the protons along their paths, while advanced cooling systems maintain the magnets at temperatures colder than outer space. These collisions are intentionally staged at 4 distinct points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, gather data. Each detector has a unique function, providing a different perspective on the aftermath of these high-energy impacts. Together, they act as immense cameras, capturing the aftermath of these crashes, with scientists meticulously examining the debris to identify elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that might illuminate the fundamental building blocks of space. By focusing on subatomic particles, researchers seek to understand the very structure of the cosmos. Nonetheless, each new discovery at the LHC raises even more questions. The LHC is not just a machine, it represents humanity's unwavering curiosity and our relentless pursuit of knowledge. It symbolizes our desire to understand the forces that shape our existence. But as we expand the boundaries of the unknown, we must confront the ethical and existential dilemmas that come with it. What dangers might arise from probing the unknown? Could our search for knowledge unleash powers beyond our control? At CERN, where the limits of human understanding are being stretched to their utmost, a disturbing realization has emerged, one that has unsettled even the most seasoned scientists. Brian Cox, a former CERN researcher and a highly regarded figure in particle physics, recently made a chilling statement that has both intrigued and alarmed people across the globe. Cox revealed that the LHC's purpose is to simulate a small-scale version of the Big Bang, essentially, a mini Big Bang. He elaborated on the immense potential of the LHC to uncover groundbreaking discoveries, such as unraveling the mysteries of dark matter, a substance that constitutes much of the universe. The possibility of harnessing the universe's fundamental forces is undoubtedly exciting, but it also comes with significant risks. The mini Big Bang is not just a theoretical idea, it is an actual event that takes place within the LHC. The collider reproduces conditions of extreme heat, pressure, and energy, mirroring the environment at the universe's birth. It's as if we are witnessing the birth of time itself. However, with such vast power comes immense responsibility. What if something goes wrong? This concern is not a new one. Back in 1978, Russian physicist Anatoly Bugorsky had an experience that forever altered the course of his life. While working with the U-70 synchrotron at the Institute for High Energy Physics in Russia, a glitch resulted in a proton beam unintentionally crossing his path. The beam, traveling at unimaginable speeds, pierced his skull, entering from the back of his head and exiting through his nose. Though struck by a flash of light brighter than 1,000 suns, Bugorsky remained conscious and walked to get medical attention. The aftermath was both astounding and terrifying. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of his injury, his cognitive functions remained intact, and he continued his scientific work. Bugorsky's experience serves as a grim reminder of the power and potential hazards associated with particle accelerators. The dangers of devices like the LHC should never be underestimated. Some scientists have expressed concerns about the possibility of unforeseen reactions that could alter the very fabric of reality. For example, there are worries that the LHC could potentially create a miniature black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces are present at the edges of the cosmos, and the idea that the LHC might create even a tiny black hole is both inspiring and terrifying. Could such a black hole grow uncontrollably, ultimately consuming the Earth from the inside out? Researchers have attempted to reassure the public, asserting that any black hole formed within the collider would be highly unstable and would disappear almost immediately. Still, the mere possibility of such an occurrence has sparked considerable debate and concern. To comprehend how the LHC could create a black hole, it is critical to understand the fundamental mechanics of a particle accelerator. When protons collide at nearly the speed of light, the energy released is so immense that it can distort the very fabric of space and time. To visualize this, imagine a tightly stretched trampoline with a heavy object dropped onto it. The fabric bends, and if the object is large enough, it can create a depression deep enough to pull anything nearby into it. This is an illustration of how the LHC might affect spacetime at a quantum level, where the laws of physics become unpredictable. A theory suggests that extra dimensions beyond the familiar 3 dimensions of space and 1 of time might exist. If such extra dimensions do exist, the LHC might have the capacity to access them, potentially forming a gravitational well that leads to a tiny black hole. This possibility has attracted the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking cautioned that the Higgs boson might become unstable at extreme energy levels, conceivably bringing about catastrophic events such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised alarms about the LHC's experiments. In his book on humanity's future, Rees acknowledged that while the chances of such an event were low, even a small probability warranted serious consideration. The stakes are incredibly high, and the margin for error is razor-thin. CERN researchers have conducted numerous simulations and analyses, taking every measure to ensure the security of their experiments. Brian Cox himself has addressed concerns surrounding the LHC. While this remains speculative, it shows the profound impact that high-energy physics could have on our understanding of the universe. If extra dimensions exist, they may offer explanations for some of the greatest mysteries in physics, such as the nature of dark matter or the unification of fundamental forces. However, the possibility of accessing these hidden realms raises more questions than answers. Could an experiment at the LHC inadvertently open a gateway to another dimension? If so, what would be the consequences? While such scenarios often belong in the realm of science fiction, they highlight the unpredictability of exploring the unknown. Beyond black holes and extra dimensions, there are also concerns about vacuum decay, a theoretical doomsday scenario in which a quantum fluctuation triggers a cascade that destabilizes the very fabric of the universe. According to some theories, the universe exists in a false vacuum state, meaning it is stable under normal conditions but could collapse if disturbed by an extraordinarily high-energy event. Could the LHC, by reaching unprecedented energy levels, accidentally trigger such a catastrophic transformation? Theoretically, if a vacuum decay event were to occur, it would spread at the speed of light, instantly annihilating everything in its path. However, physicists, including Stephen Hawking, have reassured the public that the energy levels at the LHC are far too low to initiate such an event. They argue that if vacuum decay were possible, it would have likely happened naturally somewhere in the universe over its 13.8 billion-year history. Still, these existential concerns illustrate the delicate balance between scientific discovery and the potential risks associated with pushing the limits of our knowledge. The pursuit of understanding the universe comes with ethical responsibilities. Should scientists continue to explore avenues that may carry unknown dangers? Despite these concerns, the LHC has already led to groundbreaking discoveries that have reshaped modern physics. The confirmation of the Higgs boson in 2012 was a monumental achievement, validating the standard model of particle physics and deepening our understanding of how particles acquire mass. Other discoveries, such as insights into quark-gluon plasma, the state of matter that existed just moments after the Big Bang, continue to shed light on the origins of the universe. With plans to upgrade the LHC into the high-luminosity LHC, HLLHC, in the coming years, scientists hope to unlock even more secrets. Future experiments could provide insights into dark matter, uncover new particles beyond the standard model, and perhaps even bring us closer to a unified theory of physics. The question remains, should humanity continue to explore these frontiers, despite the potential risks? The pursuit of knowledge has always been a defining trait of our species, driving us to explore the unknown, from the depths of the ocean to the vastness of space. The LHC represents a new frontier, one that challenges our understanding of reality itself. As we continue our journey into the subatomic world, we must balance ambition with caution, ensuring that our quest for understanding does not lead to unintended consequences. The mysteries of the universe beckon, and the LHC stands as a testament to human ingenuity, curiosity, and the relentless drive to answer the fundamental questions of existence. What lies ahead may be beyond our wildest imagination, but one thing is certain: the pursuit of science will continue to shape the future of humanity, for better or for worse. The draw of the unknown, the potential of discovering other dimensions, continues to captivate, despite the fact that the majority of scientists remain skeptical that the LHC will open a doorway to another universe or something far more terrifying. Should we be concerned about the potential dangers of the LHC? It's easy to get caught up in sensational headlines and fears of cosmic catastrophes. However, the reality is that scientists at CERN are fully aware of the potential risks and have taken extensive precautions to ensure the security of their experiments. They constantly monitor and evaluate their work with the highest level of diligence. The potential benefits of their research, such as unraveling the secrets of dark matter, discovering new particles, and deepening our understanding of the universe, are truly groundbreaking. These breakthroughs represent a significant leap forward in human knowledge, but they do come with inherent risks. As with all groundbreaking scientific advances, the results of LHC experiments present profound ethical dilemmas. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet or even the very fabric of reality itself? These questions cannot be ignored and must be carefully considered in the context of the broader implications of scientific progress. In conclusion, the Large Hadron Collider is a monumental achievement in human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental workings of the universe. Yet, as we explore these uncharted territories, we must remain vigilant and aware of the potential risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without challenges. The LHC stands at the forefront of scientific exploration, where theory meets experimentation and the foundations of our understanding of the universe are being tested. The journey of discovery is never without peril, and the LHC is no exception. It pushes the limits of physics, seeking to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or the very fabric of space-time itself, remain a challenge that demands thoughtful reflection. Nonetheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer us a glimpse into vast, unexplored realms of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC not only represents the pinnacle of human technological achievement but also serves as a powerful tool capable of reshaping our perception of everything, from subatomic particles to the grandest cosmic phenomena. With each breakthrough, new questions emerge, opening fresh avenues for exploration and thought. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the intersection of theory and reality. For a long time, physicists have grappled with understanding the forces that govern the cosmos: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single, cohesive framework, a theory of everything. The LHC has played a pivotal role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of specific physics but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are considerable. Yet, the pursuit of knowledge has always carried risks. However, when those risks involve altering the very fabric of space and time, the stakes increase exponentially. Could a single experiment at the LHC inadvertently trigger an event we don't fully understand, leading to consequences beyond our ability to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we delve into these uncharted realms, we must remember the responsibility that comes with harnessing such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical advancements, and a deeper understanding of the universe, are immense. The discoveries made by the LHC thus far have already transformed the scientific landscape. From the identification of the Higgs boson to advances in our understanding of dark matter, these achievements have far-reaching implications, not only for physics but also for other disciplines that rely on this foundational knowledge. As we continue to push the boundaries of possibility, the LHC serves as an example that science is never without uncertainty. No experiment is entirely risk-free, and the LHC, as grand and powerful as it is no exception. But with every risk comes the potential for monumental discoveries. The LHC symbolizes humanity's relentless pursuit of knowledge, a quest to answer the questions that have puzzled us for centuries. Ultimately, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of space and time, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. The LHC might pose risks, but it also represents the zenith of human achievement in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for millennia. Whether or not the LHC will lead to the discovery of new dimensions, open portals to parallel universes, or trigger unforeseen phenomena remains uncertain. What is certain, however, is that it is one of the most powerful instruments ever created, capable of unlocking universe-wide secrets that were once thought out of reach. The potential for discovery is boundless. As we continue our journey into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility. The experiments at CERN continue, and we must remain vigilant, considering both the possibilities and the risks, as well as the enormous potential for new understanding that lies ahead. The LHC, standing at the cutting edge of modern science, also reflects our deeper quest for meaning and understanding in a vast and mysterious universe. Each new discovery brings us closer to a fuller comprehension. As humanity ventures further into the depths of particle physics, the implications of discoveries at the LHC extend beyond academic interest. They challenge our fundamental perceptions of reality, forcing us to reconsider what we know about the nature of existence. The interplay between theoretical physics and experimental verification has already led to astonishing breakthroughs, yet the greatest discoveries may still lie ahead. One of the most tantalizing possibilities is the detection of particles or phenomena that challenge the standard model of physics. While the discovery of the Higgs boson in 2012 was a landmark achievement, physicists remain aware that the standard model is incomplete. It does not fully account for dark matter, dark energy, or the force of gravity at quantum scales. If the LHC or future colliders can provide evidence of supersymmetry, extra dimensions, or unknown forces, it could revolutionize our understanding of the universe. Moreover, the pursuit of a unified theory, one that bridges quantum mechanics with general relativity, remains one of the ultimate goals of physics. While Einstein's theory of general relativity explains gravity on a cosmic scale, and quantum mechanics governs subatomic interactions, these two frameworks remain incompatible. If experiments at the LHC can provide insight into how gravity behaves at microscopic levels, they may bring us closer to solving this century-old mystery. The future of high-energy physics. Looking beyond the LHC, the next generation of particle accelerators is already being conceptualized. Proposals such as the Future Circular Collider, FCC, and the International Linear Collider, ILC, aim to probe even higher energy levels, potentially unlocking new realms of physics. These machines could allow scientists to create and study conditions that mirror the earliest moments after the Big Bang, shedding light on how the universe evolved. Yet, as with any frontier of knowledge, ethical considerations must accompany technological advancement. The questions surrounding high-energy physics extend beyond the realm of science and into philosophy. What are the potential long-term consequences of manipulating fundamental forces? Could we one day reach energy levels that destabilize known physics? How do we balance scientific curiosity with existential caution? While these concerns should not hinder progress, they underscore the need for transparency, rigorous safety protocols, and continuous ethical discourse. A legacy of discovery. Regardless of the unknowns that lie ahead, the LHC has already cemented its place in history as one of the greatest scientific endeavors of our time. It represents the culmination of global collaboration, technological ingenuity, and an insatiable human drive to understand the cosmos. With each new experiment, physicists inch closer to unveiling the deepest secrets of reality. Whether the LHC eventually leads to evidence of new physics, alternative dimensions, or even phenomena beyond our comprehension, one thing remains certain. The pursuit of knowledge is an unending journey, one that defines us as a species and propels us toward the next great leap in understanding.